Okay, so let's do number 3 from the practice exam. So it's an arc length question. If you were to graph this, oops, it's going to look like it, maybe I should turn on my hand correcting thing. It just basically looks like this, right? You can hardly tell, if you go from 0 to 1, you can hardly tell that it's curved. Okay? And you remember that this is basically what the book called the semi-cubical parabola. And I was reading a history of math book the other day, and I found out why it has that weird name. It's because they used to think of x to the k for any number. You could call it n instead of k if you want. But no matter what this number was, they called it a parabola. So it was like a generalized parabola. So when we say parabola, we mean just that curved shape. But they generalized parabola to refer to x to any exponent. And so if you have x to the 3 halves, why is it semi-cubical? It's semi-cubical because 3 is a cube, and semi means 1/2, right? So semi-annual means twice a year, whatever. So semi-cubical, it's just 3 halves. Anyway, so how do we do this? Maybe I can remind you about the arc length formula. So let me move this stuff down. And I guess I kind of do have the arc length formula memorized, but you don't really need to memorize it. You just kind of draw a picture of, here's some curve, and here is some change in x. So here's, x. And this is dx, some little advancement in x. So there's a corresponding change in the y direction. It's actually the change, dy is really the change in the tangent line. But if we can imagine that if we're looking really, really close to x, and this value dx is really, really small, then the curve will basically be a straight line. So we can just pretend like this is a triangle, and let's call this side ds. So this is the traditional name for that side. So if you want to find the arc length, all you want to do is add up the ds's, right? So the answer is s ds. I mean the sum of the ds's. So you might get excited here and say that the answer is just s, and that's true, but then it's not clear what s is in terms of x, and so we haven't actually done any of the work yet. But to put it in terms of x, you can just figure out ds in this triangle using the Pythagorean theorem. So ds is the square root of dy squared plus dx squared. That's just the Pythagorean theorem. Alright, so we want to integrate ds. It looks a little better now, but this is still kind of weird. So you can make it seem less strange by multiplying in dx over dx into the root. If you'd rather do dy over dy, you can do that too. Alright, and now this bottom x is going to kind of go inside the radical on a mission of destruction. So when it goes inside, you get dx. The dx on top is left outside. Now when it comes onto the radical, it becomes a square. And you've got dy squared over dx squared. Okay, and this is really quantity squared, so that looks kind of strange. You know what I mean? I don't mean the second derivative here, I just mean the differentials are squared. But when it hits dx here, you get dx over dx, which is just 1. Dx squared over dx squared. So dx over dx squared is, this part just becomes 1. So you get this formula, ds is equal to, what is this? This is 1 plus the first derivative, dy dx, squared, and here's the dx. Alright, and this is something that we can do, right? So let me cut this one out. So here's the formula for arc length, which you can memorize, or you can just remember how to figure it out like this. Oh, I lost my D. That's okay, I think I can live with that. So let me push all this stuff down, or else just crazily move the cursor down to the bottom of the screen. And push. Alright, so let's do this integral that we have to do for the semi-cubical parabola. And what I have here is just the formula. Let me put the formula in the answer box for just 1 second. Okay. Alright. Oh, and when I did the integral, I should have done the integral here too, right? So this is just the answer, which is the arc length. So you have to figure out what this is. So here's the function. Here's the curve. And I need to change the typesetting in the test so that this should say y equals this. That's what makes it a curve. Okay, and now dy dx is the derivative, and so what's that going to be? The 3/2 comes down. You have 6 times 3/2, and then you take 1 away from 3/2 and you get 1/2. The 1 dies. And what happens here? You get 9. So this is 9 times the square root of x. You can see in the formula that we're not really concerned about the first derivative itself, we're concerned about its square. So what is the first derivative squared? Well, nothing could be easier to figure out. It's just this thing times itself. So it's 81 times x. Alright, great. So this is what we're integrating here. You can see that we're integrating 1 plus 81 times x dx. And there are limits. So the length of the curve between these two values. So these should be here. Alright, so we just have to take the integral here from 0 to 1. Alright, and anytime you see an integral, you've got to kind of, drool and think for a second about how to solve it. And the way you solve this one is just use substitution. So see how it's basically, it's a linear function of x under a radical. It's going to be basically the same as x squared, the square root of x. And you can get that if you just do the substitution, u equals 1 plus 81x, and then you do du is equal to 81 dx. So du over 81 is equal to dx. And I've got to make some room, so let me erase all this stuff. Alright, so plug in after the substitution. What have you got? You have 1 over 81. And what's happened to the limits here? Okay, so let's do it that way, fine. So when we plug 0 into this function, what happens? We get 1, right? And what happens to the other limit? Well, we plug 1 in here for x, and then we get 82. Alright, and so we have replaced this stuff under the radical with u. So what we have now is the square root of x, the square root of u, du. Alright, so this becomes 1 over 81 times u to the 3/2 over 3/2, and we're going from 1 to 82. Alright, and it's some number. You're going to have to figure out the number, but I'll go ahead and plug in the limits. So we've got as the answer 1 over 81. And when you plug in the top number, you get 82 to the 3/2. I don't think that's anything nice. And on the bottom, you've got 3/2, or you could just do the same thing as to multiply this by 2/3. Alright, and then you subtract away what happens when you plug in 1, and when you plug in 1, you get 2/3. Alright, and you could factor out the 2/3, etc., etc., etc. But we'll just leave it there, because I don't know what 82 to the 3/2 is going to be. But it's going to be something like, what's going to happen is you take the square root, and it's going to be basically 9. Then you raise 9 to the 3rd power, which is what? It's 81 times 9, which is something like 720. Okay, the problem's over. The problem's over.